comes the, here comes the, here comes the. Y'all don't really want it like that. Yeah. Here comes the, no. Here comes the, here comes the. Y'all don't really want it like that. Yeah. Here comes the, no. Here comes the, here comes the. Y'all don't really want it like that.
What will be the final temperature of this solution in a coffee cup calorimeter if a 50 milliliter sample of 250 m HCl aqueous solution is added to a 50 milliliter sample of 0.250 NaOH aqueous? The initial temperature is going to be 19.5 degrees Celsius, and the delta H reaction is negative 57.2 kilojoules per mole NaOH. Assuming the density of the solution is 1 gram per milliliter and the specific heat of the solution is 4.18 joules per gram degrees Celsius. Okay.
One of the first steps in coffee cup calorimetry, and in fact all calorimetry, is recognizing that the Q of your reaction is in equal but opposite magnitudes of the Q of the solution.
Here's the equations. Q reaction equals negative Q solution. Q reaction equals moles times delta H. And Q solution equals specific heat times mass times change in temperature. If you can understand these three equations, you can do any calorimetry problem. Pause your video now and make sure you have these equations written down correctly.
Given the information and the following equation, Q of reaction equals moles times delta H, we can now find the Q of the reaction.
Now remember in step 1 that you're trying to find the moles of NaOH. Now pause your video and make sure you have this correct.
As we've already been given the delta H for sodium hydroxide, all we need now to find the Q of the reaction is to find the moles of hydroxide. Assuming we have 50 milliliters of sodium hydroxide, we simply convert it to liters, use the 2.250 molarity, and we're able to get 0.0125 moles of sodium hydroxide.
In step 2, you're trying to find the Q of the reaction by multiplying the moles of NaOH that we found in step 1 by the given delta H. Now pause your video and make sure you have this correct.
Now, by plugging in the molar value we found for sodium hydroxide with the given delta H of sodium hydroxide, we're able to get our Q of the reaction as negative 0.715 kilojoules. Since we know that the negative Q of reaction equals the positive Q of the solution, we know that negative 0.715 kilojoules of reaction equals 0.715 kilojoules for solution.
In step 3, we are trying to find the mass to plug in this equation by adding 50 milliliters plus 50 milliliters and using the density equation to equal 100 grams of solution. Now pause your video and make sure you have step 3 correct.
Cut.
Using our new Q value and this equation, we have almost enough information to find the final temperature. However, first we need to find the mass. Assuming the density solution is 1 grams per milliliter, and we have 50 milliliters of hydrochloric acid and 50 milliliters of sodium hydroxide, we have 100 milliliters of solution. With 1 gram per 1 milliliter, this gives us 100 grams of the solution. Using basic algebra, we change our equation from Q of solution equals specific heat times mass times the change in temperature to the change in temperature equals Q of solution divided by mass times specific heat. Before we begin plugging our information in first, we need to make sure that our units agree. As specific heat of solution was given us in 4.18 joules per grams Celsius, not kilojoules, we first need to change our Q of solution from kilojoules to joules.
In steps 4 and 5, we will be converting our Q of reaction into a usable Q of solution. In step 2, we found our Q of reaction, and by using this equation, we will be converting our Q of reaction into a Q of solution. However, in order to use it in this equation, we need to convert it to joules. Pause your video now and make sure you've completed steps 4 and 5 correctly.
Now that we have all of our values, we simply plug them into this equation, and we get a change in temperature of 1.171 degrees Celsius. We know that the change in temperature is equal to the final temperature minus the initial temperature. Using basic algebra, we find that the change in temperature plus the initial temperature equals the final temperature. Plugging in the number we just got for the change in temperature and the given initial temperature, we find that our final temperature is 21.21 degrees Celsius.
In steps 6 and 7, by using our found values and a derivative of this equation, we can find our change in temperature. And we know that our change in temperature plus our initial temperature gives us our final temperature, which in this equation is 21.21 degrees Celsius. By using these 7 steps, you can now solve a calorimetry problem. Pause your video now and make sure you've used all these steps correctly.